Hey everybody, here's our warm-up for lesson 4-4. We're going to start talking about the Pythagorean theorem, but we'll give you a little bit of a quiz warm-up if you want to do a little bit of this first. All right, explain this picture to a friend that might have missed our last class. Our last class we talked about the hinge theorem, and in our hinge theorem we know that if you have two sets of congruent sides in two different triangles, that included angle helps you determine if the side opposite that angle, which is larger and which is smaller. So because I know that 12 is greater than 9, I know that 36 has to be bigger than 3x minus 9. So if I were to add 9 to each side, I know that 3x has to be bigger than 45, so therefore x has to be greater than 15. This is our hinge theorem, and that's where we talk about our two triangles. You can see my one triangle here in purple has the two sets of congruent sides that match up to my second triangle here in orange. And because two of those sides are congruent, I can make a story about their included angle. Because this opposite side of that angle is greater than this opposite side of this angle, I know that this angle has to be larger. All right, next up, place a star next to each side length that can make a triangle. So here's what we need. We need to look at our two smallest sides, and if their sum is greater than my side, then my triangle, then yes, it can be. If I have my two smallest, and I add them up, and they are greater than my third side, then yes, they can be. All right, let's check out these fractions. In order to put them all so that I can compare, I need to put them with a common denominator. And when I look here, I'm looking at twelfths. So I'm looking at 6/12. I'm looking at 3/12, and I'm looking at 4/12. Can I add my two smaller and have that be bigger? So 7/12 is bigger. Yep, I'm good to go here. If I have three sides that are the same, obviously these two are going to be greater than. So yep, this can be a triangle. Adding my smaller two sides together, I get a sum of 20. Therefore, this one is the only no that can't be a triangle. Okay, classify each triangle in number 2 by sides. So if I have 1, 2, 3 different sides, we're going to call this a scalene triangle. I have these two matching sides, so I'm going to call this an isosceles triangle. 3 different, scalene. 3 the same, equilater, equilateral. And then, of course, this one's not a triangle, so we're good to go. Are you able to definitively, this means absolutely without any kind of argument, classify the triangles in number 2 by angles? The only one that I feel confident doing that one is going to be this one here. By angles, I can say that letter D is equiangular, and it's also, by the way, acute. This is the only one that I can classify because even though I'd like to say I know that this is going to be a real skinny isosceles triangle, I can't guarantee without some kind of method of proving. And so not being able to say anything about these ones, I need some more information. I can make guesses, but this is the only one that I can definitively say. And guess what? That's what's going to happen in today's lesson. We're going to talk about how we can do this. All right. Solve for each of the missing angles. So this is a pretty cool picture. I know I have isosceles. So if this one's 62, so is this. So the measure of angle A is equal to 62 degrees. When we start talking about here, look, I have this right angle here. So if I know that 90 plus 62 sounds like 152, so then angle B is going to be 180 minus 152. So that's going to give me a 28 degree angle. So the measure of angle B is equal to 28 degrees. Now when I classify these by angles and sides, A, B, C, that's going to be this one here. We'll go ahead and make that pink. A, B, C. If I know that angle B is 28, and I know here that this is going to be the supplement, 180 minus 62, so that sounds like 118. Check my math on that. Okay. So this is 118. So I know ABC is going to be a scalene because the three sides are different, and it's going to be an obtuse angle. Triangle ACD is going to be an isosceles. And if this is 62 and 62, 62 plus 62 sounds like 124, and 180 minus 124 sounds like 56. So here I'm going to have an acute isosceles triangle. Now, in case you missed triangle ABD, that's going to be my big one here. And of course, we have this right angle. And I know that I have it's going to be a scalene because all the sides are different. And then, of course, a right angle. And I can double check all my angle measurements. Does 62 and 28 add up to 90? Are they complementary? Yep, they are. And then I have that 90. All right, can you list the sides in order from shortest to longest in this figure? Why or why not? So the fact that they're asking me means there's something a little sketchy about it. So let's take a look. Here I know that my longest side and my, I don't think I figured out this one here, 56 and 90. If I find their difference, 90 minus 56. That sounds like it's 34. So the picture is obviously not to scale because it has this being my opposite. So because my shortest side isn't necessarily one that I can list, let's take a look at this carefully. My AC here is going to be my opposite of my 28. So it's definitely my shortest side, then my BC, then that. So if I just look at this triangle, AC is my shortest, and then the distance from B to C, and then the distance from A to B for this triangle. Now when I look over here, because this is an isosceles triangle, my A, I don't think that that's going to work. So you think about this for just 1 minute. All right, so what are you thinking? Were you able to look at it a little bit? Because this is my smallest angle. AC is my smallest side. Because this is my next smallest angle, then I have BD or BC, and then my largest angle is C. So this is going to be the list of my sides for triangle ABC. Now when I talk about the list of my sides for this triangle ACB or ACD, triangle AC CD. CD is going to be the smallest. And then my two isosceles sides, AC and AD. Okay? So since I know AC is my smallest here, then if I want to talk about all these triangles together, these sides would have to be then smaller. All right, so the smallest distances, and I'll talk about distances, not sides. So in this whole triangle, because I know that AC is the smallest here, and it's the biggest here, I can go ahead and with confidence say CD, and I can say distance from A to D, and the distance from A to C. Now keep in mind, these are the same because it's isosceles. And then the distance from B to C, and then the distance from A to B. That's for all these sides together. All right. So now if I wanted to talk about the big triangle, when I talk about AB being my largest and AD being in here, and then of course the distance from B to D is obviously going to be the biggest. That was a tricky one. All right, good luck on your quiz.